Right now, as you're watching this, a 1,300-pound NASA satellite is hurtling through Earth's atmosphere at thousands of miles per hour. It's uncontrolled. No one can steer it, and NASA has officially confirmed it's coming down today, March 10, 2026. The question everyone's asking is, where is it going to land? And more importantly, should you be worried? I'm Azeem. Welcome back to Azeem USA, the channel where we break down the world's biggest stories so fast, so clearly, that you'll understand it before the news anchors finish reading the teleprompter. Today, we are live on the NASA satellite crash story, and I've got everything you need, right here, right now. Let's get into it. First, what exactly is this thing? Meet the Van Allen Probe A, launched on August 30th, 2012. It's part of a twin satellite pair sent up by NASA and operated out of the Johns Hopkins University Applied Physics Laboratory. Together with its twin Probe B, it was launched aboard an Atlas V rocket on a 2-year mission. Just 2 years, Azeem. That was the plan. But this thing, it kept going. 7 full years of scientific data collection. It didn't power down until 2019 when it ran out of fuel, but not before completely rewriting our understanding of near-Earth space physics. This satellite is a legend, and now, in 2026, it's coming home, whether we like it or not. So what was its job? The Van Allen probe was designed to study something called the Van Allen radiation belts, 2 massive, donut-shaped regions surrounding our planet that are packed with high-energy charged particles, trapped by Earth's magnetic field. Here's why that matters. These belts act like a natural force field. They protect Earth from deadly solar radiation, cosmic rays, and the solar wind streaming off the sun. But they're also incredibly dangerous to satellites, astronauts, and technology in orbit. Most missions avoid them entirely. The Van Allen probes? They flew through them, on purpose, for years. And the results were groundbreaking. One of the biggest discoveries? The probes found a third radiation belt, a temporary ring that appears during intense solar storms. That was never seen before. It changed textbooks. Hundreds of scientific papers were published from this data. This wasn't just a satellite. This was one of NASA's most productive science machines. Now here's where it gets really interesting. Because this crash wasn't supposed to happen yet. Original calculations predicted Van Allen Probe A wouldn't re-enter Earth's atmosphere until 2034. That's 8 years from now. So what happened? 2 words: solar maximum. The sun runs on an 11-year cycle of activity. Back in 2024, scientists confirmed our sun hit what's called the solar maximum, the peak of its most active phase. And this cycle? It's been way more intense than anyone predicted. When the sun is hyperactive, it blasts out solar flares, coronal mass ejections, and bursts of radiation that expand Earth's upper atmosphere, literally causing it to puff outward like a balloon. That expanded atmosphere creates more air drag on satellites in low to medium orbit. Think of it like running through water instead of air. You slow down much faster. And when a satellite slows down in orbit, it drops. Gravity pulls it in. And that's exactly what happened to Probe A, 8 years ahead of schedule. Okay, the question you all came here for. Where is this thing going to hit? The honest answer? Nobody knows exactly. And that's not NASA hiding something, that's just orbital physics. When a large object re-enters an atmosphere at orbital speeds, even tiny variations in atmospheric density, solar activity, and object tumbling cause massive changes in the final landing zone. The window of uncertainty is plus or minus 24 hours, which means the satellite could land anywhere within a ground track covering thousands of miles. What we do know is the impact zone, anywhere between 52 degrees north latitude and 52 degrees south latitude. That covers a huge portion of the globe, from northern Canada and the UK in the north, all the way down to southern South America and Australia in the south. That includes major cities: London, New York, Tokyo, Sao Paulo, Cairo. The list goes on. But, and this is important, 71% of Earth is ocean. The statistical probability is that whatever fragments survive re-entry splash down in open water far from any populated area. NASA's confirmed this. The U.S. Space Force is tracking it in real time at Link. So picture this. Probe A hits the upper atmosphere at roughly 17,000 miles per hour. That's orbital velocity. The moment it starts punching into denser air, friction superheats the surface of the satellite to temperatures exceeding 3,000 degrees Fahrenheit. That's hotter than lava. Most of the satellite, about 80 to 90% by mass, will completely vaporize. The aluminum body, the solar panels, the wiring, all gone, burning up in a spectacular fireball visible from miles around. But here's the thing, some components won't burn. High-density materials like titanium fuel tanks, stainless steel bolts, and certain structural components can survive the heat. NASA estimates that some fragments from Van Allen Probe A will make it to the surface. So yes, pieces of this satellite could hit the ground. Or the ocean. The question is which? NASA officially stated the risk of anyone on Earth being harmed by this satellite is 1 in 4,200. Let me put that in perspective for you. You have a better chance of getting struck by lightning in your lifetime, which is roughly 1 in 15,300 per year, but 1 in 1,222 over a lifetime, than you do of being hit by this satellite. The 1 in 4,200 figure accounts for the entire global population. Your personal risk is astronomically lower. Experts stress that in the entire recorded history of the space age, over 60 years, no human being has ever been confirmed killed or seriously injured by falling satellite debris. There is one documented incident from 1997 where a woman in Texas was grazed by a fragment of a Delta II rocket booster, but no injury occurred. Bottom line, you don't need to evacuate. You don't need a bunker. But you should absolutely keep watching this video, because the space debris crisis, the bigger picture here, is something that does affect your future. Here's what this satellite crash really reveals and why it matters beyond today's headlines. Right now, in 2026, there are approximately 14,000 active satellites in orbit around Earth. And in addition to those, scientists estimate there are more than 130 million pieces of orbital debris, from paint flecks to entire defunct spacecraft, whipping around at 17,000 miles per hour. In January 2026, a study published via Science Daily warned that low Earth orbit is just 2.8 days from a potential cascading collision disaster, what scientists call the Kessler syndrome. That's the scenario where one collision triggers another, then another, until Earth's orbital space becomes completely unusable, blocking future launches for generations. We also have Starlink deploying 4,400 satellites this year. China's mega constellation is growing. Amazon's Kuiper project is launching. And the International Space Station, the ISS, has been officially scheduled for a controlled deorbit crash into the Pacific Ocean's Point Nemo by 2030. The Van Allen probe crash today is a preview of challenges coming at us fast. Space agencies, private companies, and governments need to act now. This is one of the most underreported crises of our time. So what's being done? NASA and the U.S. Space Force's 18th Space Control Squadron are tracking Probe A in real time. You can actually follow the updated reentry predictions yourself at link, all public, all live. NASA's Orbital Debris Program Office at Johnson Space Center continuously monitors reentries and updates risk assessments. The agency has also been developing new guidelines requiring future satellites to have deorbit plans built in from the start, so we don't keep ending up in situations like this. The European Space Agency has launched its Clear Space mission, designed to physically grab and deorbit space debris. A company called Catalyst Space Technologies has even been contracted to try to save a different NASA telescope, RHESSI, from an uncontrolled crash through a never-before-attempted orbital servicing mission. The solutions exist. The technology is coming. But the question is, are we moving fast enough? Van Allen Probe B, the twin of today's crasher, is currently still in orbit. NASA says it won't re-enter before 2030. But given how aggressively this solar cycle has accelerated Probe A's decay, that date could move up too. Watch this space. The bigger question, how many other satellites are silently ticking toward uncontrolled reentry right now? The answer is hundreds. And as we launch more, particularly with Starlink, OneWeb, and other mega constellations, the frequency of these events will increase. This is not a once-in-a-decade story. This is going to be a once-a-week story within a few years if we don't get serious about orbital debris management. The era of consequence-free space launches is over. Every satellite we put up now has a life cycle, and we need to own every phase of it, including the end. All right, Azeem's hot take. NASA handled this responsibly. They were transparent, they communicated the risk clearly, and they've been tracking this in public. That's what good science communication looks like. Give people the facts, not the panic. But here's my concern. For every Van Allen Probe A that gets this level of media coverage, there are dozens of other dead satellites and rocket stages coming down with zero news coverage. We got lucky that this one had a clear orbit, a known mass, and enough lead time to track. Not every reentry will be so neat. What do you think? Drop your questions in the comments. Are you worried about space debris? Do you think private companies like SpaceX should be held to stricter deorbit standards? Let me know, and if you're watching this live, super chat me your hottest space take right now. That is going to do it for today's breakdown of the NASA Van Allen probe, a satellite crash happening right now on March 10th, 2026. This is history in real time, and you caught it here on Azeem USA. If you got value from this video, I need you to do 3 things for me right now. 1. Drop a like on this video. It literally takes 1 second, and it helps this information reach more people who deserve to know what's happening above their heads right now. 2. Hit that subscribe button and ring the notification bell for all alerts. I cover breaking science and world events the moment they happen. You do not want to miss what's coming next. 3. If this content adds real value to your day, consider supporting the channel directly. You can send a super thanks right below this video. Any amount means the world. If you're watching this on a live stream, super chat me. I read and respond to every single one. Or go even deeper and join the Azeem USA membership. Exclusive content, early access, members-only posts, and a direct line to me. Link is right below the video. Every single member makes this channel possible. I'm Azeem. This is Azeem USA, and I'll see you in the next one.